Greetings to everybody. Welcome to this demo session on Mentormatics. I am Snigdha and I will be teaching chemistry from middle school, 10th grade. Okay, my qualifications. I passed high school last year through the CBSE board. My 10th grade marks were 90% and my 12th grade marks were 87%. I gave a few standardized exams such as MSAT, which is a standardized exam in UAE, and I have also given IELTS in which I got 7.5, and I've given a few medical school exams in Europe through which I got admission in Pet University and Debrecen University. So I'm on Mentormatics because this opportunity allows me to make a difference in a student's educational experience by building basic concepts for academic development. This is a very crucial stage for basic concepts for the future. So I hope to build the basic concepts and help people make their academic journey easier. Okay, moving on to the demo now. Chemical reactions and equations is a chapter in 10th grade. So it has the following contents, and I'm going to be teaching Introduction to Chemical Reactions and Equations today. So, chemical change versus physical change. Why do we need to know chemical change versus physical change? To understand a chemical reaction, we need to know what is a chemical change. Okay, so if there is a change in the chemical composition of a substance, then we say that it is a chemical change. But if the chemical composition of the reactant remains the same, and it is a physical change. Now, if we properly know how to identify chemical changes, then we can identify when a chemical reaction and a chemical equation occurs, and this makes our chapter very simple. So, chemical change. Chemical change is the alteration of molecular composition. Okay, that means the nature. Very simple. That means the nature and identity of the substance alters. Okay, and it is relatively faster than physical change. Chemical change is always irreversible or permanent. For example, you have a piece of paper that you burn, you put it on fire, it burns, it turns into ash. This ash cannot give us paper again. This ash can never give us paper again. So, this is a chemical change. And we also see that paper gives us ash, which is a completely new product. So one or more products are subsequently formed, which are completely new products. So this is a chemical change. Now, physical change. Physical change is the opposite of a chemical change, in which the molecular composition is not at all affected. Only the shape and size, that is the physical state, changes. For example, we take the same paper and we cut it. It is divided into two new papers which are broken, which are cut. Only their shape and size has changed, nothing else. It is a relatively slower change, and in some cases, not in all cases, but in most cases, and it is reversible in most cases. In this case of the paper getting cut, it's not reversible because you can't get the paper back. However, the paper has not turned into wood. It is still paper when it is cut into two parts. Yes, so it is a physical change. Now, if you take the same paper and you make it into an aeroplane, okay, the shape and size are changing, so it is a physical change. However, the aeroplane can be made back into paper, so it is a reversible change. So we can see here that most physical changes are reversible and some are not reversible. Okay, but all chemical changes are irreversible. Okay, and physical change, no new products are formed. In both cases of the paper, paper still remains paper, whether it is cut into two papers or it is an aeroplane. Paper is paper in both cases. No, nothing has been formed. We didn't get wood from paper. Paper is still paper. So it's a physical change. Now, chemical changes. In the following situations, we have to recognize where the nature and identity of a substance has changed. It has changed boiling of water to produce vapor. Okay, over here we have water. We can see over here that we have water. Water produces vapor. When water boils, it produces vapor. Okay, how is this a physical change? This water is still water when it is vapor. The chemical composition is the same, whether water is a liquid or water is a vapor. And this vapor can be turned into water again by condensation. So it is reversible too. So it is a physical change. The next example we can take is bending of copper to form a wire. So as we all know, copper is Copper can be bent to form wires. Okay. This wire is copper. Whether it is a block of copper or a wire, it is still copper. Copper is copper in both cases. Whether it is bent in the shape of a wire, it is still copper. Copper has not turned into anything else. So since the chemical composition has not changed and we do not get any new products, it is a physical change. Next, we're going to talk about rusting of an iron screw. Over here, we have iron. When this iron reacts with O2, okay, we get rust, which is ferric oxide, FeO2, Fe2O3, sorry. Okay, this is rust. Uh, okay, rust. Rust is a completely new product, and rust cannot give us iron again, can it? It cannot. So it is a chemical change. Next, we get milk. Milk getting left at room temperature during summers. When we leave milk at room temperature during summers, on the milk there are some microbes which convert the milk into a sour substance, or it converts the milk into curd. This cannot turn back into milk again. So once these microbes have changed the milk into a sour substance, or they have changed it into curd, it is completely transformed and it cannot be turned into milk again. So it is a chemical change, okay, not a physical change. Food getting digested in our bodies. So when different types of foods, carbohydrates, proteins enter our body, these complex and big molecules of food have to get broken down into smaller particles that can be absorbed by our blood and tissues, right? So this is done with the help of some acids in our gut and in our digestive system. And it is these complex particles are broken down into simpler forms. Since it is broken down and these simpler forms cannot go back to the complex form again, it is a chemical change. Simple as, okay? Freezing of water. Now, since we have discussed a lot, it is pretty obvious what freezing of water is. Freezing of water is a physical change. And that is a very simple example because water is just turning into ice. This ice can be melted and be made into water again. Okay, so this is a physical change. Food getting cooked. Okay, when we cook food, we are breaking down the complex particles such as complex proteins into, we are breaking down so that they are broken down into simpler substances that can be digested in our body. Moreover, we are also killing all the bacteria on our food. This cannot be reversed. So it is a chemical change. And respiration. When we respire, when we take in oxygen, this oxygen is used by our tissues to make energy for the body. And this energy cannot give us oxygen again, can it? So this is also a chemical change. Okay, moving on, we have a special case over here, which is a candle. When a candle burns, okay, so when a candle burns, the wax flows up to the wick, and the wax acts as a fuel. This wax acts as a fuel. Okay, wax acts as a fuel for producing heat and light. So what do you think this is? This is a physical change. When the wax melts, some of the wax goes up the wick, and this wax acts as a fuel for producing heat and light. So wax turns into heat and light, and we cannot get wax back from this. So this is a chemical change. Whereas some of the wax melts. This is a melting wax. So this wax has only changed its shape and size. It has not changed its chemical composition. So this is a physical change. So this is a nice case of a candle burning where we see both physical and chemical change happening simultaneously. So I hope that chemical and physical change is clear, and now you can identify what a chemical change is. So link between chemical change and chemical reaction. Okay. Process of chemical change, change in identity, nature, and chemical composition is chemical reaction. So when a chemical reaction occurs, that means a chemical change has occurred. So if you can identify where chemical changes have occurred in your daily life, you should know that it has occurred because of a chemical change. Okay, simple as that. Chemical reactions are represented as a chemical equation. So when we describe a chemical reaction, we can go on describing about how the reaction has occurred, right? We can write paragraphs about it, we can talk about it, we can write a word equation about it. But if you want to simply explain a chemical reaction with using symbols and symbols of the elements and symbols such as plus and equal to and arrow, we get a chemical equation. A chemical equation is basically a shorter and faster way of representing a chemical reaction in terms of symbols and formulae of different reactants and products. So, this is what a chemical equation is. Chemical equations represent a chemical reaction using symbols and formulae of different reactants and products. So, chemical equations make your chemical reactions easier to put into words. Okay. Chemical reactions are represented in the form of a chemical equation. Chemical equations consist of reactants and products. Done. Chemical equations. Chemical equations. Okay, so in a chemical equation, over here I'm saying that we have a chemical equation. On the left hand side, we have the reactants. On the left hand side of a chemical equation, we have the reactants. And on the right hand side, we have the products. And they are separated by an arrow. And on top of the arrow, sometimes you can have catalysts. For example, in the case of rust, the catalyst of rust is humidity, water, and salty air, etc. These increase the speed of rusting. These help in rusting. So on top of the arrow, in the reaction for rust, you would write all this. So you can write catalysts which help the chemical equation on top of the arrow. Reactants and products can be separated by the plus symbol when there are many reactants and products. Okay, this point has already been discussed. So this says what a chemical equation is. A chemical equation is something that represents a chemical reaction in an easier way. Now, this is something that we need to note. The same number of elements on the reactant side are present on the product side. Okay. Okay. So here we have a few activities that demonstrate chemical reactions and make it more simple for us to identify when a chemical reaction has occurred. Activity 1. This is the setup for the activity. So over here, we have a magnesium ribbon. We clean it with sandpaper. Okay. After cleaning the magnesium ribbon with sandpaper, so first of all, let me tell you why we clean the magnesium ribbon with sandpaper. The magnesium ribbon is coated, the magnesium ribbon has already oxidized in the air because it's very reactive. So now if you want the magnesium ribbon to work in your experiment, you need to clean the layer of the oxidation and then start with the magnesium ribbon. So clean it with sandpaper and then hold the magnesium ribbon with a pair of tongs like where I'm pointing. Then using a burner, burn it, okay, and ash will form. Collect this ash on the watch glass. Now, what do we observe? Observation is that the magnesium ribbon is burning with a dazzling white flame and it turns into a white color powder. This powder is magnesium oxide and it is formed due to the reaction between magnesium and oxygen present in the air. So over here is the formula Mg plus O2 is equal to MgO. Left hand side we have the reactants, right hand side we have the product, and this product is the white powdery substance. What do we infer from this whole activity? We infer the change in nature and identity of the magnesium ribbon, and we infer the change in color. Okay. Now, activity number 2. The steps are simple. Take lead nitrate solution in a test tube and add potassium iodide. Lead nitrate and potassium iodide formulae are given over here. PbNO3 twice and Ki. They are both colorless liquids and they both have water-like appearance. Both are colorless, both have water-like appearance. Now let's see what happens to both of them. They are both colorless. Over here in the picture, I have depicted that if you mix that if you have PbNO3 twice and you put Ki to it, they become yellow in color. How? This is the entire equation, and this equation will be taught further on when we come to types of reactions. So PbI2 is a yellow precipitate. Okay, so what do we observe here? We observe the formation of a precipitate. We observe the formation of a color. Okay. Okay, so what do we infer from this? Formation of a new product and formation and change in color. So because of completely new product, both were colorless, but now the product has become yellow in color. And because of the change in color, we can infer that there has a chemical reaction has occurred. Now we take activity number 3. Okay. Activity number 3, you have to use a conical flask or a test tube, anything. In that you have to have zinc granules. Over here you can see zinc granules, right? Into these zinc granules, add hydrochloric acid, HCl, or add H2SO4, sulfuric acid. Okay. Now you will observe a few changes. This is the formula, by the way. This is the formula. When this is done onto the zinc granules, when you add an acid, this is the product ZnSO4 and H2 gas. Okay. Now observations. Bubbles are formed around the zinc granules, and there's an increase in temperature. Okay. What do we infer from this? We infer that there has been a chemical reaction between the zinc and the acid. Due to this, the bubbles have formed around the zinc. This bubbles is basically gas, H gas. This gas is the result. This gas is the product. This is formed around the zinc. Okay. And the temperature of conical flask increases. So there's an increase in temperature when the new product has been formed. The gas forms to give bubbles and temperature increase to give bubbles. So in these 3 activities, you have seen in the inferences that there are so many different kinds of changes when a chemical reaction occurs. From this, I can conclude this entire thing in this one page. The above 3 activities, we can say that the following observations help us determine whether a chemical reaction has taken place. These 4 statements should be asked whether when you want to check whether a chemical reaction or a chemical change has taken place. Change in the state, change in the color, change in the evolution of gas, and change in temperature. Change in state can be explained when the ribbon has turned into powder. Change in the color can be explained when we get a white powder from magnesium ribbon. Okay, powder becomes completely white. And evolution of gas. Also change in color when the two colorless liquids have been used in the reactant side, you get a yellow precipitate. So this is change in the color. And then finally we have evolution of gas. Evolution of gas. You see that H2 gas has evolved in the last activity, and this gives bubbles. And lastly, change in temperature. Change in temperature when ZnSO4 plus H2 gas was formed. Okay. So these are the characteristics of chemical reactions. Ask yourself this question when you want to check whether a chemical change or a chemical reaction has occurred. Not only do you ask if it is an irreversible reaction, not only do you ask if a new product has been formed. From now on, you have to ask these 4 objectives to know whether a chemical reaction has occurred. So this was the introduction to our chapter. The rest of the chapter will be taught further on. I hope this demo was good. Thank you.